The golden ratio. So again, when we talk about proportion, we talk about rule of thirds and the golden ratio. There are many different ways to say the same thing here. So sometimes it's referred to as golden mean. Sometimes you'll hear golden spiral or golden ratio, golden section, or divine proportion. Some of you may have seen this previously. This is what it looks like. So in ancient Egypt and Greece, philosophers, artists, architects, and mathematicians studied nature to find the spatial relationship that represented the most efficient and harmonious use of space. And what was discovered is this golden section, or the divine proportion. Some of you maybe have heard of the Fibonacci series. So really it's this rectangle with a 5 to 8 proportion. What the golden ratio states is 1, 1, 2, 3, 5, 8, 13, 21, 34, on and on and on. What this is each succeeding number after 1 is equal to the sum of the two preceding numbers. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so on. And so what happens from all of this math is we get this ratio formed, and it's 1 to 1.618, and it's called the golden mean. And so there's ratios that are the same. Ratio of B to C to AB is the same as AB to AC. So there's a little geometry for you. Basically what we care about is that this golden mean occurs very frequently in nature. And some say that we as humans might be genetically programmed to recognize this ratio as being pleasing. Okay? Now the golden ratio is not as well known as the rule of thirds, but a lot of photographers and artists still utilize this. A lot of architecture has utilized this. Now when we look at talking about this ratio occurring naturally, it occurs in nature, and we find it again and again and again, from the shape of a seashell to the shape of a horn to the double helix that makes up our own DNA. Actually, when you look at a study of top fashion models, it reveals that their faces have this ratio, this 1.618 ratio. And so you can see this kind of as an example where someone has divided it up to show you that ratio. Now, in a little bit more complicated way, we can make all kinds of guidelines from this ratio. And so if you study this for a moment, you'll see that we start with that larger rectangle. And basically what you do is you subdivide it, and you end up from the large rectangle, you end up with a square. Let me draw this out for you. Right here, we have a perfect square. So we end up with, from the rectangle, we end up with another perfect square, and the size of the rectangle as the remaining from the perfect square. And what happens is you just keep subdividing it and subdividing it and subdividing it. Some of you maybe have heard of the Parthenon in Greece. So this is a view from the west in Acropolis, Athens. The date of this, 448 to 432 BC. Notice that this golden ratio was utilized in the architecture. So we've used this for lots of years. It's been around us for as long as we've known. So now your goal is to see if you can utilize this in your photography. It's a little bit more difficult than the rule of thirds. Rule of thirds is super basic, right? It's that tic-tac-toe over top of your photo, and a very easy way to compose your photos. Utilizing the golden ratio or the golden mean is a little bit more tricky. What might happen is as you go through some of your photos that you've created in your library throughout the semester, you'll start to notice that, hey, I think this one might have it. And just simply laying this framework over top of your photo, you might find that you, yes, indeed did find that golden ratio or the golden mean. So the key thing here, rather than trying to force yourself to fit your photography in the golden ratio, or force yourself to fit your photography in the rule of thirds, think about these two questions. What are the points of interest in this shot? And where am I intentionally placing them? So keeping those two questions in your mind as you're out taking photos will help you achieve really great composition.